Welcome back to our lesson practice review for Chapter 1, Lesson 9. Our lesson summary, to kind of recap here, is all talking about scaling our function vertically. And to do that, we're going to be multiplying the outputs by some factor. So the key words that we got to make sure we understand here is that if we multiply that by something greater than 1, it stretches it vertically. Whereas when we multiply a factor between 0 and 1, like a fraction or decimal, then the graph compresses it vertically. And so when we look at these two situations, the first one on the left here is when we are multiplying it by 2, that would mean that we are stretching it vertically. So we can see that these points here, and if it starts out with a y value of 1, then it multiplies by 2, so it becomes a y value of 2. When this one we have a y value of 4, it gets multiplied, and now it's an output of 8. Whereas we see that it's stretching in this case, meaning like it's getting taller. Whereas the second situation is that if we multiplied it by 1/2, you can see that our original function f of x, output of 1, now the output becomes 1/2. Output of 4, now the output becomes 2, because we're multiplying those y values by 1/2. And we can see that it's getting a little bit squatter, it's getting shorter in terms of the y values. So let's see that in practice here with question number 1. It asks us to select all the expressions that represents a function that is reflected over the x-axis. So recap on that, right? If we think about what it looks like here, if we have some function like a parabola, it reflecting over the x-axis would mean that it is looking like this. And so important that I write that out, because we're seeing that our y values are being multiplied by -1, or the outputs are being multiplied by -1. So what that means is that any expression here that represents the output being multiplied by a negative number, that will reflect it over the x-axis. So that includes b, e, and c. For number 2, the maximum of f of x is 4, and the minimum is -4. Order the expressions based on the distance of the maximum or minimum to the x-axis from closest to furthest. So again, kind of explaining what that means, right, is that let's say we have some function that goes up to +4, down to -4. That's our distance between the x-axis would be 4, because both the top and the bottom are 4 units away from the middle of this function, or the x-axis. So we're looking for which ones are closest to that. So which ones are, compressing vertically versus stretching vertically. So in this case here, I'm going to look for which one's multiplying by a number less than 1, which would be, in this case here, 1/8. And I guess technically -7 is less than 1, but we'll talk about what that means in just a second. But with 1/8, that is compressing it vertically, meaning that all these y values are now being multiplied by 1/8. So it's getting much closer to the x-axis. So this would be, the first, or the closest to the x-axis. I guess I'll rewrite this here. 1/8 f of x, that's our one that's closest. Then the next would be 2. It's no longer a fraction, but it is stretching. Oh, I lied. It's stretching it. So that means that our original function has to be the next one, because this one here is 4 units away, whereas when I multiply it by 2, now it's going to be 8 units away. So f of x comes first, then 2 times f of x. And now here's the tricky part, is that it's technically -7 times f of x next. The reason for that is because when I look at, this idea here, the negative reflects it, but it doesn't change how far it is away from the x-axis. The only thing that changes how far away it is that number there, whether it's positive or negative. That's what's talking about, is it stretching or compressing. And so in this case here, the next one would be -7 f of x, and then our farthest away would be 9 times f of x, because that's what's giving us the largest values, or distance away from the x-axis. Kind of a tricky one there. Problems 3 and 4. Write an equation for b of x as a transformation of a of x. So for number 3 here, when I'm looking at this, I can see already that it is a reflection. And it also looks like it is going to be stretched by a factor of 2, because I can kind of see, if I zoom in here a little bit, I can see that this has a y value of 1. If I were to reflect it, it would land here, but now it's giving me an output of -2 instead of -1. So it's a reflection and it's being stretched by a factor of 2, which means that I would say b of x is equal to -2 times a of x. For number 4, I'm going to look at the same general idea. It doesn't look like any reflections are happening here, but it does look like it is getting compressed vertically. So if I were to take, let's say this point here is at 0, 8. Well, now we're at a point here of 0, 1. So it's getting compressed by a factor of 1/8, because it's multiplying all those values by 1/8. 1/8. So next up, for number 5 and 6, we're asked to write an equation for d of x in terms of c of x so that the graph goes through the plotted points. So in this one here, I'm going to be looking at it, and I can kind of see that these points here, this first one now goes here, second one goes here, third point goes here. And so when I look at these points, right, let's call this one here in the middle here 0, 1. Well, now it becomes 0, 4. So immediately my first thought is it being multiplied by 4? I'm going to double check that with this next point over here, which is at 0, 2. Now, sorry, not 0, 2, 1, 2. Now I look at this next point here is at 1, 8, and that confirms, yes, I am multiplying that by 4, or it has a stretch factor of 4, which is telling me I'm going to say 4 times c of x. For d, similar idea here. I'm going to take these points, start with the vertex. I like that one the best. That starts at 0, 3, and this goes up to 0, 9. So I'm thinking that this is going to be multiplying by 3, but let's double check. This one is at 1, 2, and now I get something that is 1, 6, and that does confirm it, that we are multiplying c of x times 3, c of x. All right, number 7 is the statement always, sometimes, or never true. The x-intercepts of a function remain the same as you scale the function vertically. That is always true. The reason for that, I'm not going to write this, but I'm going to just kind of talk about it, is that whenever you're scaling a function vertically, you're just multiplying the y values or the outputs by a number, right? When we kind of look up here, we kept all the same x values here at 0 and 1, at 0 and 1. We were still maintaining the x values to be the same. The y values are the only things that were changing, or the outputs. So for number 8, we're asked to, using the digits 1 to 9 only once, transform f of x so that it intersects the y-axis at 3 different odd numbers. So right now it intersects the y-axis at -4. And so the first thing that I would think of is that if I were to divide that by 4, or multiply by 1/4, then it would compress it so that it crossed at the odd number of 1, which makes things really simple, right? So my first idea here is I'm going to be multiplying it by 1/4. Now, I'm not sure if I want to use that because I may need those numbers elsewhere. The other idea here is that we have this thing with a double-digit denominator, which is kind of a pain, so I'll probably actually put numbers in there first to make it easier. But the first idea is I need to multiply it by 1/4. The other idea, though, is that when I'm looking at this, is that once I multiply it by 1/4, I could then multiply it by 3, also known as multiplying it by 3/4. And that would also give me an odd number because it would divide by 4 and then multiply by 3, giving me an intercept at an odd number 3. And so really anything like 1/4, 3/4, 5/4, 7/4, 9/4, and so on, like I could just keep going on and on and on to give me an odd intercept. So I need to come up with a couple different ways of writing that because I can't use 4 more than once. So that being said, when I'm trying to get this big denominator here, I would recommend using 12 because I know that is divisible by 4, and it gets rid of, I don't have to do this really giant denominator. It's the smallest denominator I can do with double digits here. And so when I do 12, what that would mean is that if I put 3 in here, that would just simplify to 1/4, which I know would give me an intercept at an odd number. I'm going to need to do another couple of versions of these. I'll go ahead and do, let's say, 7/4 here. So now I've used 1, 2, 3, 4, and 7. And so the next one that I could do, I need it to simplify. So the denominator needs to be divisible by 4. So I could do 8. And then that would make this have to be, it could be 6. Because again, what that then does is that, I'm going to do this in colors, 6/8 simplifies to 3/4. We have 7/4, oops, give me green here, 7/4 works, and then 3/12, which simplifies to just 1/4. So all of those would give me odd intercepts. Again, the idea is because my current intercept here is at 4 or -4, then I have to divide by 4 to make it 1, which is odd, and then I can multiply it by any odd number, which would give me a different intercept. It would stretch it accordingly to help me. All right, for the spiral review, 9 and 10, change one number in each equation so the outputs of the functions are closer to the x-axis. And so in this case here, to make it closer to the x-axis, all I really want to do is change the a value or the stretcher compression value. And so in this case here for number 9, g of x, I could just change that to, let's say, 4, and that would compress it vertically or make the outputs closer to the x-axis. For h of x, same idea, or for number 10, I want to be changing this multiplication or this stretch or compression value, this vertical scaling, to make it smaller. So if this is currently 1/2, if I made it 1/4, then that would compress it more or make all of my outputs closer to the x-axis. That wraps up lesson practice for chapter 1, lesson 9. Next up is lesson 10, and we're getting close to the end of the chapter.